Hello, welcome to everyone. In this video, this is our lecture number 16. Already 15 lectures actually covered. On this lecture, from lecture number 1 to 7, we discuss the solution of the differential equation by Frobenius method and specially discussed the Laplace polynomial, Lagrange polynomial, Bessel's function, and Hermite differential equation. After that, lecture number 8 to lecture number 14, we discuss about the solution of partial differential equation by separation of variable method, and especially discussed mainly the Laplace equation solution, then wave equation solution, and conduction of heat. These are application actually discussed in this lecture series. So if you want to watch the previous lecture series, you can go through the description box, link are given there. In the last lecture, that is lecture number 15, we discuss about the total of this Fourier series and some theorem of Fourier series, some example, and that in that video we give you some homework, some question, and I think we you are already watch this video and you will try this problem solution. In this video we want to discuss the solution of this problem given in this lecture, that is 15, and some question asked in the IIT-JAM and JEST examination. Okay, so additionally we want to discuss some question which were previously asked in these two examination, IIT-JAM and JEST. You know about this thing, that is this examination are the entry in these IITs for the master degrees, and this is for the entry for the PhD in the different institution, right? So we will be just wants to discuss about some questions which was asked in the from the Fourier series in these two examination previously. Okay, so let's start today's discussion. You can watch this is the syllabus for the BSc physics honors, third semester, University of Calcutta. This portion we will discuss in lecture number 1 to lecture number 7, and this partial differential equation, this is discussed in lecture number 8 to lecture number 14, and in the fifth lecture number 15 we discuss this, and this is 16 also discussed in the Fourier series. Okay, in the upcoming video we will want to discuss this some special integral, that is the beta function, gamma function. Okay, this is will be the upcoming video. Lecture number 17 will be the this portion. Okay, so I think clear about the root of the lecture series, right? So let's start. The question was, first question was the find the Fourier series expansion for this function f of x. Define is like that. Okay, you all know the method of this Fourier series. This Fourier series can be taken as f of x is 0 by 2, n equals to 1 to infinity a n cos n x plus b n sin n x. Since this limit is minus pi to plus pi, so we will take this in the form, this Fourier series in this form, where a0 equals to 1 by pi minus pi to plus pi f of x. You know 0 to pi is one limit and minus pi to 0 is another limit. Put these two limit, you can get this is pi. Similarly for an, this is 1 by pi minus pi to plus pi f of x cos n x, and separate out these two limit because these are two value, and just putting this you can easily find out this an equals to like that. And you can say, see if n equals to even, so this become 1, so this is 0, and for n equals to odd, this become like that. Okay, if you want to draw this curve of this nature, you can see here that is this is x, this is f of x. You can see here that is the 0 to pi, this is x, that means like that, and 0 minus pi to this is minus x, so this will be like that. So this is a symmetry, this is a symmetry, this is a symmetry curve. So you can see this symmetry curve, you can see this bn will be 0 for sorry, for symmetry means even function, and you know for even function bn equals to 0, so you can directly return bn equals to 0 from this property. Otherwise you can find out the bn like that, that is the f of x like that. Just putting this limit, separate out these two limit and putting the f of x, and then integrating, you can easily find out this bn equals to 0. Clear? I think clear. If there is any doubt, you must comment in the comment box, or directly you can write bn equals to 0, since this is even function, and you know for even function bn 0, and for odd function a0 and an also 0. Clear? So if you put this value a0 and an, you will be get this expression. Just expanding in, the solution will be like that. Clear? Next question. Next question was the function Fourier series are given here. Prove that this will be. This is Parseval theorem. You can easily prove just taking this integration, and this is the average value 1 by pi. So for each term there will be 3 terms. So if you taking the square, you will be get, there will be 1 2 3 4 5 6 6 term you will be get, right? There is a 3 whole square, you will give 6 time. So this is square, that square, this square, and multiplication of these two, and these two, a plus b plus c whole square, like. And this integration of this thing, integration, that is the total loop of cos is 0, total of sine is 0, total sine cos also 0. Sine square cos square gives you half, and this is gives you like that. Okay, so I think you can do this integration very easily. This 3 term it gives you 0, and this 3 term, this is gives you half means pi by 2 to total limit by 2 2 pi by 2 2 pi by 2, and this is gives you 2 pi. So finally you get this thing. Clear? This is the proof of the Parseval theorem. Next question. So that y equal to f of x, where limit is minus L to plus L, is an even function, then its Fourier series is a cosine series. So this is a proof. That's I just saying that the for even function, this bn equals to 0, there is no sine function. This need to be proved. Okay, no problem. So taken is a even function, so f of minus x equal to f of x, this is same thing. So this Fourier series expansion like that, so a0 equals to like that, and an equals to, you can say this is a even function, and this is also even function, those total is even function. Since total is even function, you will be get, you can write down this thing. And since this is a odd function, from the sorry, this is a even function and this is a odd function, multiplication of even function and odd function gives you odd function. Since this is a odd function, you must write down this is 0, because this is a odd function. For in case of odd function, minus a to plus a limit, the integration will be 0. So you can directly say that bn equals to 0. That means only an and a0 is exist. So the cosine function a0 and ax is exist, this is not exist. So sine is not exist, so the Fourier series will be the cosine Fourier series. Clear? So in case of the even function, Fourier series will be cosine. In case of odd function, you can see in case of odd function, this is odd, this is even, this becomes odd, so this must be 0, and this is odd, this is odd, total become even, this is not equal to 0. So in case of the odd function, this will be sine series. Clear? I think clear. Next question. Can y equal to tan x be expanded in the Fourier series? This can be expanded in the Fourier series. This will be the question. You can see this is a continuous function, no problem. This is a periodic. This tan function also a periodic function, right? And there is a finite number of discontinuity, because this continuity is the finite number. You can see there is only 2 discontinuity within this interval. Now these two satisfy, but there is another property, that is the Dirichlet condition. You all know, if you was the previous lecture, you all know about the Dirichlet condition. That said, that is minus a to plus a, that means this limit, this limit will be must be finite. But if you find out this integration, you can see there is a tan infinity, sorry, tan pi by 2, there is a mistake. This is tan pi by 2, this is nothing but this is infinity. Since this is infinity, so you can say that is the this is infinite, so this is not satisfied Dirichlet condition. That's why this is cannot be expanded in the Fourier series. I think clear about the solution of this question. Next question. Determine the Fourier series expansion of this function. This is a function given, you need to form Fourier series expansion. Very simple, just taking out, you can see this is a even function, so bn 0, directly you can say bn equals to 0. Since this is a even function, you can directly say bn equals to 0, so you need to find out a0 and an. So a0 is nothing but 1 by pi minus pi by 2 plus pi f of x dx. So put the f of x and taking integration, you will be get a0, and an, just for the an, put this f of x cos nx and f of x like that, and taking this integration, just taking the bypass integration here, you can easily find out this is the value of an. So put this value an, because bn equals to 0, put this value of an, you can easily find out this solution. I think clear about the solution. Next question. Expand f of x equals to a. It is a constant in a range that is 0 to pi in a Fourier series. Hence, so that this, okay. So since this is a given, you can see this is a half range, so you can take this is a odd function in the another range. So the by Fourier theorem, you can say there will be, since this is a odd function, only bn is exist. So bn equals to like that, you can just find out this bn equals to like that. For n equals to odd this is, and for n equals to even this is 0, and f of x will be like that, only bn is exist. So f of x, put this value of bn and expanding, you can get these things, and put x equal to pi by 2 such that we can find out this expression solution. Clear? I think clear. But we can take, here we take this is a odd function, we can also take this is a even function, there is no problem. If there is even function, the bn part is 0, you will be obtain a0 and an, and a0 is nothing but like that, you can see this is 2a, and an equals to like that, you can see this is 0. So we cannot find out any infinite series solution, so this cannot be taken here. Clear? So you need to take this odd function and you can find out this process. I think clear. Next one, this question asked in IIT-JAM 2018. You can uh, pause this video and solve yourself. After that, you can continue the video. Clear? I think you clear about my motivation, about my target. That is, you try yourself first. After that, you continue this video. Clear? So the function is given here and expand in this Fourier series form like that, which will be the true. Clear? You can see, if you draw this curve, you can see this 0 to pi, this is minus x, and minus pi to 0 is plus x, so this will be like that. Okay, so this is the even function. Since this is the even function, bn must be 0, a0 not equal to 0, an not equal to 0. So you can directly say that is the answer. A is the correct answer. A is the correct answer. But also, if you wants to find out this value a0, you can easily find out this is minus pi by 2, and bn you can easily find out this is 0. In this process you can also, but if you can draw this graph, you can easily solve this question very quickly. Clear? Next question. This is asked in JAM 2017. This function is given within period 2 pi. Ratio of the Fourier coefficient of first and third harmonic. You need to ratio the first and third harmonic. So for that you must find out this coefficient. We just find out a0 is which is 1, an which is 0, and bn which is like that. For even this is 0, for odd this is 0. So after that we can get the solution. This is summation of the solution. That is the take the summation, just expanding, you can see this is the solution. Now you need to find out the Fourier coefficient of first and third harmonic. This is a constant part, this is not harmonic term, these are the harmonic terms. So the first harmonic term coefficient is 2 by pi, and the third harmonic term is 2 by 5. 5 pi. 2 by 5 pi. I think there is some mistake. Minus pi by 2 plus pi. This is a 2. Sorry. 2 by sorry, no, this is 0 to pi by 0 to pi, this is 1, so this is x pi, right, this is 1, no problem. So this is the half, and this is the half for 5 pi by 2, this becomes 5, sorry, first harmonics and third harmonic, first, second, third. So half, and this is 2 by 3 pi, so half, this is 3 pi by, so 3 pi by 4. Clear? So 3, and this is 3.14 by 4, this is nearly equal to 9 by 4, this is nearly 2. Answer will be B. This is B. nearest integer will be b. Clear? I think clear. This nearest integer. So this will be the b is the correct answer of this question. Right. Next question. Which says this Fourier series given by this function like that. If f of x equal to x in this region 0 to pi, you need to find out b2. So you need to just find out b2. You know bn equals to like that. Here this limit l is changed into pi, so l becomes pi. Put l equals to pi here. Put l equals to pi here, and this is the x. The function will be the x, and limit will be 0 to pi, and this is to pi by 2, because this total interval is 0 to pi, so this half interval, that is pi by 2, right? So just taking this integration, you can easily find out this is the minus 0.5. Okay, I think you can do this integration very well. Next question. The Fourier series for the arbitrary periodic function 12 as given by like that. So this is the Fourier series which are given like that for the particular periodic functions. So this is are given here for a particular periodic function, so that the find out the value of a0. So you need to you can see here, this is a symmetric function, this is a symmetric function. For -1 to 0, this is minus x, and for 0 to 1, this is x. So this is a symmetric function, that's mean a even function, so a0 not equal to 0, that's it. From here you can see find out this 2 into 1 by half, 2 into 1 by half, 1 by 1, that is the 1 by pi, 0 to, since this is a even function, so we can take limit is 0 to 1, and they are multiplied to integration formula of integration 1 by this limit which is 1, and put this is x dx, so the integration gives you value 1, answer C. Next question. In the Fourier series expansion periodic function, this is a periodic function which is mod of sin x. Which of the coefficient is non-zero? So this is the even function. Since this is a even function, beta n must be 0. So these two are cancel out. Only alpha n is exist. So find out the value of alpha n. So the same thing. This is a even function. That's why limit 0 to pi by 2, and there is multiplication of 2, and the half limit is pi by 2. Right. So take this formula and integration you can get here. When think about here, when n is odd, so this become even. Since n is odd, so n minus 1 and n plus 1 both are even. And in case of even into pi by 2, sine even into pi by 2 must be 0. Sine even number into pi by 2, this must be multiplication of sine pi, this is 0. In case of n, if n is even, these two are odd. Since these two are odd, so since these two are, and their separation is 2, that's mean one must be in that region, and another in that region. That's mean one is plus 1, another is minus 1. So these become non-zero, those become non-zero. So in case of n equals to even value, when n is even value, alpha n not equal to 0, so answer will be B. I think clear about the concept here like that. Next question, which asked in JEST 2017, which says that is the function f of x is cos hyperbolic s. This is it is the different question which are discussed in the previous one. This is a different. You can see here there is a hyperbolic function f of x is cos hyperbolic function, where this range is given minus pi by 2 plus pi x repeated between this region. That means periodic function, right? Where m equals to minus pi plus pi. Fourier series indicate the correct relation when x equal to 0. So which relation will be satisfied, you need to find out. Clear? You need to take just simply process. You can see this is a even function, so bn is 0, no problem. Take find out a0, simple process, and find out an in the process. Just taking the, cos hyperbolic x, the cos hyperbolic x is nothing but e to the power x plus e to the power minus x by 2, and sine hyperbolic x equals to e to the power x minus e to the power minus x by 2. That's why integration of cos hyperbolic x is nothing but the sine hyperbolic x. Clear? I think you all know about this relation which are discussed in the complex number, right? So the an equals to like that, you put this value of cos hyperbolic x, and they separate out these two term, and find out this integration 1 by 1. Take I1 equals to integration e to the power x cos nx. e to the power cos nx, this one. Okay, so if you integrate by parts, taking in the integration of exponential and derivative of cosine function, so the derivative of cosine function, and this is the integration, and then again derivative of sine function, integration of exponential, and then rearranging, this will be the, I think you already done this type of integration in class 12, right? So I1 will be like that. In case of the I2, you just put this e to the power minus x, and you can just integration, you can get relation, will be like that. Okay, so put these two things for I1 and I2, and getting this value will be like that. Okay, that's no problem. This is the value of an. So putting this value within this expansion, this f of x equal to cos hyperbolic x, and put this value of a0, and then value the an, the coefficient an is written here. So this coefficient an and cos nx equal to, write down here. Now you need to put this x equal to 0. If you put this x equal to 0 in this expression, you can see here, when cos hyperbolic 0, when cos hyperbolic 0, put x equal to 0, you will be get this relation will be like that. Okay, so sine hyperbolic pi, write down here, and put this here. You can see here, just sine hyperbolic pi, write down there. You can see here, this cos 0 is 1, and then rearranging in this integral value in right hand side, and this is in the left hand side, like that. Just rearranging, you will be get this solution. I think clear about this process. If there is any doubt, any confusion, you must comment in the comment box. So that's it for today. This is all about me, and this is my contact details. You can connect with me with this telegram channel, and this is my online platform, and this is my youtube channel details. Go to this channel, you will be get some physics related video. Also you can get some mathematics in your general part, that is numerical problem, lpp also is you can get in this channel. You can go through this channel, like this session. If you learn something from this session, share this video in, uh, if you wants to share this video to your friends, either he or she also get benefit from this video. Subscribe this channel if you new in this channel, and those already subscribed, thanks for subscription. Press the bell icon to get the notification of upcoming video. In the next video we want to discuss about the special function, that is the beta and gamma function we want to discuss. So stay connected. So thank you.